Hello everyone, today I want to talk to you about some of the properties and the calculations of the continuous random variables. First, let's define the random variable. Consider an interval x to x plus 30. Second, given an event of x and the probability, like this. Third, now take 30 to 0 and measure how the probability of x changes. Then we can get the probability density function of continuous random variables like this. And we can calculate the probability of any interval a to b getting the following formula. If given a joint PDF xy, we can get a marginal PDF like this. If x and y are independent, then we have the joint PDF of x and y equals the multiply of marginal of x and y for all x and y. We can judge whether x and y are related from whether the correlation coefficient between x and y is equal to 0. The calculation formula is given as follows. But the converse is not generally true. Independence can introduce correlation, but correlation can be independent. Convolution formula. Given a function z equals x plus y, we can get the PDF of z. The condition is x and y is independent. We can get this formula. Last, I give one example about continuous random variables. Let the density function of the random variable x, y be this equation. First, find the marginal PDF of x and y. Second, prove the correlation and the independence of x and y. Third, if z equals x plus y, find the PDF of z. Below, I give the answer to the question. The first question, to find the marginal distribution of x and y, we use the theorem of the previous explanation to give PDF of x and y. The second question, to prove whether x and y are independent, we calculate the PDF of x and y respectively and prove whether they are equal to the joint distribution of x and y. Practice has proved that these two relationships don't want to wait, so x and y are not independent. Then we calculate the correlation coefficients of x and y to get the correlation coefficient of x and y equal to 0, so x and y are irrelevant. Finally, we calculate the PDF of z according to the convolution formula. From the range of values of x and y, we can go to the value range of z. Okay, this is some of the properties of the continuous random variables I introduced today. Of course, discrete random variables have similar properties, so you may wish to have a try. Thank you for listening.